The distributive property in mathematics is, I believe, one of the most important ideas found in math, all the way from primary school to upper level calculus. Many people use the distributive property in everyday life without even realizing they are using it. In this video, I will explain what it means and how it can be used. To start, I put a problem up here, 513 times 4. And I'd like you to solve this particular problem in any way that you can without the use of a calculator. So I'd like you to pause this, do the problem, and then start this back up again. Okay, hopefully you've had a chance to do this problem. Let me talk through what I believe many people do when they do this problem. Probably many people use the traditional algorithm when they do this problem. And the very first thing they do is they multiply 3 times 4. 3 times 4 is equal to 12. Put down the 2. Carry the 1. 4 times 1 is 4, plus 1 is 5. And then 4 times 5 is 20. So many people do it the traditional algorithm way and get 2052, which is certainly a great way of doing this particular problem. But let me talk about doing this problem a different way. If I have 513 times 4, I could really do the same thing. I'm just going to write it down a little bit differently. 3 times 4 is equal to 12. So I'm going to put the 12 all the way down here in the partial product area. Then I'm going to multiply the 1 times the 4, but that 1 is in tens place, so it's 10 times 4, which is equal to 40. And then I'm going to multiply the 5 times the 4, but that 5 is in the hundreds place, so it's 500. So 500 times 4 is equal to 2000. Then I could go through and add up all these numbers, and once again I would get 2052. Now, I know many people might argue that why in the world would we even think about doing the problem this way when it's so easy to do the problem that particular way? Well, I would agree. If you know the algorithm, that certainly might be an easier way to go through and do the problem. But this way of doing the problem is really the distributive property. Because what you are doing is you are distributing the 4 over each one of these numbers. 4 times the 3, 4 times the 10, and 4 times the 500. And that really is what the distributive property means. It means distributing one number and multiplying it by the other numbers that are in there. Sometimes, instead of doing this problem up and down, you might do the problem across, like I have here, 513 times 4. Once again, I could go through and I could distribute that 4. Now this time I'm going to do 500 times 4. I'm going to multiply the 500 times the 4 with the 5 being in the hundreds place, plus 10 times 4 because that 1 stands for 10, plus 3 times 4. And then once again, I could go through and I could figure out 500 times 4 is 2000, 10 times 4 is 40, 3 times 4 is 12, and I could add all those numbers up, and once again, I would get that answer of 2052. So many people ask me at this particular point, why in the world would I choose to do it one of these two ways rather than this traditional algorithm way? Perhaps one of the reasons why I would choose to use the distributive property over the traditional algorithm is because I can do it quickly in my head without writing anything down on a piece of paper. If I have 513 times 4, I know that 500 times 4 is equal to 2000. I know that 10 times 4 is equal to the 40. I know 3 times 4 is equal to 12. And quickly in my head, I can add together that 2000 plus 40 plus 12 to get that 2052. If I wanted to with 513, I could even break up that 513 just into two different numbers, 500 plus 13. And then I'd be multiplying both of those things by 4. And once again, 500 times 4 is equal to 2,000. I know 13 times 4 is equal to 52. So once again, add those up together in my head, I would get 2052. Using the distributive property allows me to mentally do the problem rather than relying on a piece of paper, a pencil, or on a calculator. How about a two-digit number by a two-digit number? For instance, 62 times 34. Once again, if you were going to use the algorithm for this, many people in learning the algorithm would go 4 times 2 is equal to 8, 4 times 6 is equal to 24. Then put down the 0, and many people always question why in the world are we putting down a 0, but we'll do it, that is the algorithm. Then 3 times 2 is equal to 6, 3 times 6 is equal to 18, and then you would add up these numbers, and you would get 2,108 for an answer. Well, you could also do this problem using the distributive property. And in school these days, oftentimes students are introduced to the distributive property by using a method known as the box method. So let me illustrate the box method, which is really the double distributive property. If I have 62 times 34, one thing I could do is I could break up that 62 into 60 plus 2. And I could do the same thing with the 34, and I could break that up into 30 plus 4. Then, really what I'm doing is I'm multiplying together. To get the answer for this box, I'm going to multiply the 60 times the 30. 60 times 30 is 1800. In order to get this particular answer for this box, I'm going to multiply the 2 times the 30. 2 times 30 is 60. In order to get this particular answer, I'm going to multiply the 60 times the 4. 60 times 4 is 240. And in order to get this answer, I'm going to multiply the 2 times the 4. 2 times 4 is equal to 8. So now what I have is I have all my partial products inside the boxes. And notice that this 1800 plus the 60 is 1860, which is the same thing that I have right here. And the 240 plus the 8 is 248, which is the same thing that I have right here. Once again, adding these together, I get 2,108. This distributive property really is a great way of decomposing the numbers and making sure that it's understood why this multiplication algorithm over here does work. Unlike the last problem that we did, this is not a problem that I would tend to do mentally. I would just get out a calculator, 62 times 34, and quickly have the answer. But it is great to see that the double distributive property also works with this. Here's another example of using the distributive property, but this time using the distributive property of multiplication over subtraction. Let's say that you had to multiply 5 times 799. Once again, you could certainly go through and use the traditional algorithm, but that would be a lot of work. I could, if I wanted to, go through and do this particular problem instead of as I have 5 times 800 take away 1, because 800 minus 1 is equal to that 799. Now I could go through and use the distributive property. I'm going to multiply that 5 times both the 800 and the 1. 5 times 800 is 4,000. 5 times 1 is 5, but I need to subtract. So 4,000 minus 5 is equal to 3,995. This is a great example showing how I can use the distributive property of multiplication, as I said this time, over subtraction, and I can do this mentally in my head much quicker than I can go through and do the traditional algorithm. So let's take a look at a real-life problem and see how the distributive property can be used, if you want, in order to solve the problem. Tom bought 50 blue ribbons and 30 red ribbons for a project. Each ribbon, regardless of color, cost $3. How much did he pay? Show two different ways of determining the answer. Well, certainly one way that you could go through is you know that every ribbon here cost $3. So I could take $3 times, I have a total of 50 plus 30 ribbons. So that means I have $3 times 80 ribbons, or I have a total cost of $240. Now that's not using the distributive property, but I could go through and do this problem by using the distributive property. Once again, I have $3 times 50 blue ribbons and 30 red ribbons. Using the distributive property, I would distribute the $3 times the 50. $3 times 50 is equal to 150, and then I would multiply 3 times 30. 3 times 30 is equal to 90, and once again I get an answer of $240. It doesn't really matter which of the two methods you end up using, but it is important that you understand that you could distribute that 3 amongst the 50 blue ribbons and the 30 red ribbons in order to come up with the answer. You can also, as I said in the very first part of it, you could just add those ribbons together. This way of doing it, though, is something that will become important, especially when we're doing algebra, which is why I am introducing this to you now, the distributive property of multiplication over addition, or as we showed earlier, over subtraction. So let me just give you a couple of practice problems to do before ending this video. On the left-hand side, I have 84 times 6, and I would like you to use the distributive property of multiplication over addition to solve that particular problem. On the right-hand side, I have 6 times $3.99, and I would like you to use the distributive property of multiplication over subtraction to solve that problem. So if you would pause this and go through and do those, and then turn this back on again, and you can just check your answers with mine. Okay, hopefully you have had time to go through and do both of those problems. On the left-hand side, I asked you to do that particular problem using the distributive property of multiplication over addition. So in order to do that problem, the very first thing I would do is to multiply 80 times 6. And I know that 80 times 6 is 480. And then I would multiply 4 times 6. 4 times 6 is 24. And I would then add those two numbers together. 480 plus 24 gives me a final answer of 504. On the right-hand side, I asked you to use the distributive property of multiplication over subtraction. So if I were going to do that, I would be, first of all, rewriting this as 6 times $4 minus a penny. And now I'm going to distribute that 6. So I'm going to multiply 6 times $4. So 6 times $4 gives me $24 minus, now I have 6 times a penny. 6 times a penny means I have 6 cents. So now I'm going to subtract $24 minus 6 cents, would give me a final answer of $23.94. At the end of the first video in this module, I asked you to complete a quick check to gauge your understanding of the concepts in the video, and I would like you to do the same thing again. If you do well on the quick check, you may be ready to take the quiz on this module. There are also additional review problem worksheets or other websites that you can access after the quick check if you would like to continue to review the concepts. As always, you can also contact me for additional help if you would like. Thank you.